All right. So notice that it says 4.3, and you're like, what happened to 4.1, 4.2, Mr. Dirksen? That's just obtuse triangles, which you've been dealing with since the beginning. I kind of just mixed it all up. Why wait, right? If it's working the same way, why would we separate them? But when you go to 4.3 in the textbook, remember chapter 3 and 4 are both dealing with trig. But 4.3, we're told that there's an ambiguous case of the sine law. Remember, it's not saying cosine law. It's just a problem when the scenario you're dealing with involves the use of the sine law, meaning you somehow come up with a pair. And I will be honest with you, you will know when you have to worry about this. Okay? It's going to be kind of like a how many possible solutions are there scenario. So I'm going to walk you through. So you don't necessarily have to be worried about it every single time. But like I kind of set the stage when this is what I want you to start thinking about, right? And so only an issue when dealing with SSA in particular. So, right, we narrowed down between the two laws. It's only sine law that has this problem. And it is in particular with an SSA case, side-side angle. So you either draw your diagram and figure it out, or I'll show you a little cheat here. If you ever get something like this, triangle ABC, let's just stick with triangle ABC, right? And you're given angle C is 40 degrees, let's say. I would write this down if I were you. And they give you two other sides. So let's say they give you side B is 5 centimeters. Don't try to solve this because I'm not sure if it's going to work. And side C is 15, let's say, centimeters. So you're looking at that and you're like, okay, side, I have two sides and I have an angle. But when you graph this could actually be a cosine law, right? These two sides could be sandwiching the angle in question. So what you need to look for is this. The fact that you have this angle, angle C, and you have the side that's across from it. So this sets the stage that it's going to be sine law for sure, and you're given one more side. So see that pair and a side, pair and a side, then you know it's SSA for sure. You don't even have to draw this thing. Okay, so pair. I've just thought of it now, that's why I didn't leave room for it, of course, right? Pair plus side, that therefore SSA. Can you see that? I feel like it's a little small, right? And if you miss that, right, you will find out once you start graphing it, right? You'll start finding out, oh yeah, this is SSA, right? This is the pair and the one side. So keep that in mind. When you see that, boom, you know what, that this will be an SSA. You don't even have to graph it, right? So if let's say you're thinking, well, how could this be different? It could have been side B and side A, right? Side B and side A given, well, none of these two sides is directly across this one. That's a cosine law. That will be a cosine law scenario where the two sides are sandwiching that one angle given, okay? All right, let's keep going here. And I also have my iPad ready here because I will give you a cool visual demonstration of what we're talking about here in a bit. As mentioned earlier in the unit, cosine of an obtuse angle results in a negative ratio. So example, cosine of 100, right? We expect, we don't know what the value is in particular, but we know it's going to be negative, right? So that is negative. Now I mean cause an issue, right? We'll just go like this. It's a negative 0.17 and it keeps going. Focus on the negative, okay? Applying the inverse of cosine to a negative ratio will result in an obtuse let's capitalize that, obtuse angle, right? So let's say you're taking the inverse of a negative cosine ratio, so second cosine, and as soon as you type in negative 0.234, notice that I just made that up, right? You know, because of that negative, that this is going to be greater than 90, okay? So this is 103.53. However, let's say you forget the negative. So I'm going to copy that previous line and you forget the negative, right? It's going to be an acute angle. And I want you to notice something. What do you think is going to happen if I add these two? That one plus, yeah, you have a feeling it's going to be 180, right? It's exactly 180. So what's happening here? What's happening in the background? Well, I would like you to start thinking that every angle has its supplement. So I'm not going to butcher this if I do it here, but you always have to think of a straight line. And let's say the 103 is here, right? 103.53 is the obtuse angle created by this line that's cutting the horizontal. And on the other side, you have the 73.48 if you round that. No, sorry, 47. If you round that. So if there's a negative ratio, it'll find this. Cosine will find this one. If the ratio is positive, it'll find the acute angle, right? So cosine knows how to distinguish between the two. Cosine does. Sine law doesn't. Sine law will, by default, even though you're trying to find an obtuse angle, will always give you the acute. Always give you the acute angle. So that's the problem with sine law. What about sine? Let's explore this. We omit tangent since we're not using it, right? So you could have a chart like this, and the book does have tangent, the tangent ratio, but we're just going to look at sine and cosine. So what is this weird looking graph here? So we're going to go through a bunch of scenarios. I give you a bunch of angles here. And so let's figure out if theta, you remember the letter theta, the variable theta, that's just like the variable for angle, right? If theta is 20, then what is this saying here? 180 minus theta. That is actually called the supplement, right? We're finding a supplement. Write that down at the top. So if theta is 20, then the supplement would be 180 minus theta. This would be 160, correct? If theta is 50, then this would be 130. And if this is 75, then this would be 105, right? So I'm already filling in the angles. So remember, these two add up. But you need to know this. The code, this is code for supplement. Okay, if you ever see this, it's code for the supplement of the other angle. Okay. So let's figure this out. Follow me here. So sine of 20, we're gonna do sine of 20 here. You can just follow along and copy if you don't want to type, right? But this is 0.3420. We're gonna do 4 decimals. Sine of 50 is 0.7660. Sine of 75. There's a pattern that I'm going to show you. That's why I'm doing this. I'm not a big fan of charts like these, but when you can see stuff after filling it in, then yes, I like it. So we did sine. How about cosine? Cosine of 20 is 0.9397, right? Cosine of 50, that's 0.6428. Cosine of 75, 0.2588. Right? Let's head over to this other side of the sub. We're going to do the same thing with the supplement. Sine of 160. Watch this. What do you notice? What do you notice between the two? They're exactly the same. No distinction. Cosine of, sine of 130, exactly the same. So let's just cut to the chase and just copy that last value, right? These two are exactly the same. And cosine, I kind of spoiled it already, right? Like it's not going to be a surprise here, but cosine of 160, what do we expect it to be? For sure negative, right? But there's something else cool about it. Watch. Negative what? You notice that that value is the same, 9397. It's the same value except for it's negative. And so I'm going to cut to the chase, and I'm just going to copy. So if I ever do this, if I ever say, hey, cosine of an angle that is acute is this, can you predict what the cosine of its supplement would be? And the answer would be, yep, it's the same value, it's just negative, right? You should know that. So cosine of 105, I'm going to copy its supplement, that value, but I'm going to make sure there's a negative in front of it, right? And a couple things. If the angle is acute angles, right, you get positive, positive, right? If the angle is obtuse, you get positive, negative. So something to notice here, right, is that cosine makes a distinction, right? Sine doesn't. Right? And here's where I'm going to do this here as well. Right? I'm highlighting all the negatives. And notice that the numerical values between the angle and its supplement is always exactly the same. The value itself, it's just the sign that changes. Okay. So if I told you, hey, the sine of 105 is this, predict the sine of this supplement, like the supplement of this angle, you should know it's 0.9659 without even using your calculator. Okay, so that's something newer for you. I'm just going to move my mouse here. There. Let's fill in. All three trig functions return a positive value for acute angles. All three functions have the same numerical value for an angle and its supplement. Numerical, right? So the actual numbers that you see are the same for both. It's just that only cosine, right? And tangent, and you're like, you didn't do tangent, but that's okay. Cosine and tangent return a negative value for obtuse angles. Sine will give the exact same value. Sine will give the exact same value and sine for both acute and obtuse, right? This is where the ambiguity is going to come from. Ambiguous is when you're not quite clear, like, hey, what are you talking about here, right? That's exactly the same approach we're going to take. Sine does not distinguish between acute and obtuse and will always return, right? So sine will always return an acute angle. That's a problem. Cosine and tangent will have the same numeric value. However, it'll be a positive ratio for acute. I'm saying the same thing in different ways. Do you notice that? Like I keep on trying to make that point, right? And a negative ratio for obtuse angles, okay? In general, we will conclude, right? So this is where I sum everything up. Sine of the angle is going to be exactly the same as sine of, this should not throw you off, right? Theta is like this. I just make a circle and I come around like that. Okay. It's exactly the same. Cosine of theta, I'm going to use a red pen here. Cosine of theta is not going to be exactly the same. It's going to be, you're going to have to throw in a negative in front of it and then follow it with cosine of 180 degrees minus theta. For the equation to equal out, you're going to have to throw that negative in front of it because this is going to return a negative, right? And I'm just throwing tangent in there as well, just in case. You're going to have to do the same thing. Okay. Promise you we'll do math in a bit. Just hang in there. Okay, so let's go over here. Page 29. This diagram is actually drawn to scale. Okay, I use GeoGebra for that. GeoGebra. That's a free app. You can download it on your phones, on your tablets, whatever, and you can start making shapes, and it will actually give you the exact units. It doesn't tell you centimeters, inches, whatever, but you can just make that up yourself later. But calculate the measure of angle A using sine law and cosine law. Diagram is drawn to scale. And you're like, what? 2 laws? You always told us you can only do one, Mr. Dirks. But I gave you enough information that you can, in this case, do both. So let's figure out angle A here. I think you can do that actually, right? But I'm going to do cosine law first. I have side, side, side. Do you notice that? Okay. So cosine of A is equal to the first number I write down. Notice that I use 4 decimals, or sorry, 3 for some values. Just go ahead and use all of them. And so make sure you square it. And then it's 6.168 squared plus 7.82 squared. You should remember that. And it's 2 times 6.168 times 7.82. I will actually, because I need the space on the right side, I'm going to continue downwards. So I'll figure out what the top is. If I type in the top, you get a big number. Well, lots of decimals. Negative 58.330977. Okay. And 9646752. Because I would already assume you know how to use the cosine law. We're just cutting to the chase here. So angle A would be cosine inverse, and let's make this a little shorter here. 58.3 dot 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 right over 96.4 dot dot dot. And when you run that, as you would already, I told you this, I kind of spoiled it all, right? I didn't want to wait for this moment. I wanted you to start thinking of it already. But you expect an obtuse angle, and indeed it's 127.21. Okay, so cosine law, no problem. It knows that that is an obtuse angle, even if you didn't draw it, right? Not that cosine law can see your drawing, but right, like it knows that it's supposed to be an obtuse based on the sides that were given. Let's try sine law here. And I spoiled that one too already, right? Sine law by default will only give you the acute. So, is there an acute angle here at A? It doesn't look like it because you're focusing on what? You're focusing on the triangle, right? Sine law is a little sidetracked, right? Like sine law is like, no, 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 no. I see an acute angle right there. That's the one I'm going to find, right? That's how sine law kind of, it's a silly way of thinking of it, but that's what sine law does, right? So let's go ahead and do that. So sine of 23.049 over 6.168 is equal to, and I want to find A, right? So sine of A is 12.551, like that. Sine of A is what I'm trying to find. That's my variable. So you cross, multiply, and divide. Don't forget that, right? We haven't done a whole lot of finding angles with sine lately, so I don't want you to forget it. So for this to work, I have to use more decimals or else it will be off. Turns out that we're going to be very close, but not quite. So when you do all of this, the next step is sine A. I run this through my calculator and I get 0.7941. And you might be thinking, Sudarshan, I remember saying something about a negative. I want an obtuse, but sine now doesn't have that. It will never be negative. If it does, it's gonna give you an error. So angle A is sine inverse of 0.7941 dot dot dot, right? I used all decimals. And so I get 52.57, right? You know already that that's wrong. And let's do something real quick here. I'm going to highlight that and just show you here on this triangle that you found that angle in there. Okay. So you'll say, but angle A is obtuse. So if I give you a triangle that is drawn to scale, right, I'll ask you, hey, and I'll set it up in such a way that you have to use sine law. And you do the math and you're like, oh yeah, 52, 57, moving on, right? But if this thing is drawn to scale, you must, right? You must watch out, right? Like, because you're going to have to say, oh, wait a minute, I found the one outside. I need to find this one. So all you have to do is angle A is 180 minus 52, 57. That's the only way to do it. And you get 127.43. So we still are off by a little bit, but it's very close. Right? So I will highlight both of these angles here that it sticks out, and I will highlight that angle that we actually were asked to solve for in yellow. Whatever you have, whatever color, just make sure it matches, right? This is the angle we want. Sine law has a problem, right? With it always wanting to find the acute angle, even though it's not there, not inside the triangle, right? That's what it does. So that's the problem with sine law that we have to watch out for. Only when it's side-side angle, though. Do not worry about it if it's not side-side angle. And you're gonna have to. That's gonna take a little bit of a. It's gonna be a learning curve for you to get that. Okay, let's do a little bit of just this part right here. The bottom part is just to see if you understood that first page we did. Okay, so yeah. Yeah, always. Yeah. There will be, when you do word problems, some of you will choose to stick with cosine law throughout the whole thing. And some of you will be like, no, I'm done with cosine, I will switch over to sine law. It will be a bit off. As long as you show me the work, you will not lose any marks. Yeah. I know that it's going to be off by a little bit. Yeah. Okay, state if the following statements are true or false, right? So we're going to see that. But I want you to have this, and maybe this check mark is study sheet material, right? I don't know what you, but what you want to check for when I give you these statements is, Are the angles supplementary, right? Do they add up to 180, right? You can just say, do angles add up to 180? Check, right? Does the equation have opposite signs? Right? Does the equation have the same signs? So these are kind of things that you're looking for, okay? So last resort, which we always have available, is use your calculator to show whether or not it is actually true. But cosine of 7 is equal to cosine of 173. The first check is going to be this. Do they add up to 180? They do, right? So that's checked. Now you can continue, because if it's not 180, done. It's false right away, okay? Cosine of 7 degrees is not the same as cosine of 173. It's not. Watch. Cosine of 7 is 0.9925. 0.9925. And what's cosine of 173 without using your calculator? You're paying attention. All right. So that's not the same, so false. Right? They're not the same. You'd have to slap a negative in front of one of the sides for that to work. Okay. So you can use your calculator, or I'm going to start using what I see. Okay. Are these supplementary? Definitely not, right? So false right away. They're definitely not the same. This thing only works if you have the angle and its supplement. That's when you can start seeing that the values are going to be the same. Here, adds up to 180, check. Is sine of 80 the same as 120? Oh, sorry. You got me. That's like 200, so that's not equal to 180. Sorry. Mr. Jackson, what are you up to there? Okay, this is false. We're done. Yeah, don't even bother continuing. If it doesn't add up to 180, everything falls apart. Are these two equal to 180? Yep. So now you can continue your pattern. Do you think this would be accurate to say? And the answer is yes. Watch. If you have cosine being compared and one of them is negative, it doesn't matter where it is, but one of them has to be negative, this is actually true, right? This is true. And here's how you prove it. Watch. You go cosine of 120, that is negative 0.5, correct? And you're saying that the other side will be negative, right? And what's cosine of 60? Without using the calculator, you already know it's 0.5, right? And that negative there makes sure that both sides are equal. So yes, that checks out to be true. Okay. Keep going. I want you to figure out which ones of these would be true or false. Do a couple. I'll just update my attendance and I'll be back. You know, guys, you're good anyways. There's some other students that aren't good. Anyways, so here we go. Check for 180. Yes, right? And tangent, you need to have opposite signs. You need to. And you're like, is it always in front of the obtuse angle, Mr. Dirksen? No. But there needs to be a negative, so this is actually true. And some of you use your calculator, and that's fine. Right? Do these add up to 180? That's the first check I would do, right? 180. But then there's a problem. Sine, you cannot have different signs because these values are going to be exactly the same, right? So this is actually false. Does this add up to 180? Yes, it does. Opposite signs, true. That's how easy this is, guys. And this one might have thrown you for a loop here, but this is actually 180, right? And they both have a negative. It's okay. That is okay. As long Like for them, you want the same sign, right? There's the equation. This is for sine law, right? And this is for cos and tan. You want opposite signs, right? And so there we go. I'm going to skip the next few questions actually, because I want to get going with the next what this unit is really about. So we've explored that sine law doesn't make a distinction between acute and obtuse, and this is where the problem comes up. So come with me. We're gonna go for a journey here. And you're like, what about those pages that we're skipping? I always add more than what I need. Like quite often I'll add more than what I need just in case. So maybe tomorrow we'll just do a few more. But here's the meat and potatoes of this section, guys. Applying the ambiguous case of the sine law, SSA, right? We're gonna explore this a little bit. All right, so here we go. We need to determine the number of solutions that are possible when it comes to this. How many triangles are possible? Let me do that here. Number of possible triangles, the same thing as number of solutions, okay? So add that to your notes. When you're given an oblique triangle, notice that it's SSA, right? We determine that it's SSA, which is sine law. We need to take extra precautions, especially when there's no diagram provided. This is on page 35, okay? Page 35, especially when there's no diagram provided. And before I do anything, okay, I'm going to set the stage here. Sometimes when you read the question, you're going to draw it in a weird way. It's not going to look like this. But if you determine that it's SSA, you want to force it to be like this, where the angle that is known is going to be here. This is sort of like the ground. And notice that this is not me. I can't trademark this. I got it from another teacher. But, you know, the fishing rod and the string, it's easier to think of it like you're standing here and you're lifting the rod and this is the fishing line, right? That's the string with the hook. And watch what I'm going to do next. We don't worry about any other cases, okay? It's only SSA, okay? So before we do this, I want you to look at this here. Hopefully you can see that. Okay, so this is GeoGebra as well. So there is a problem when it's SSA, right? So if you have the angle here, and this is your fishing rod, and the other side given is, this is what? From here, from the top to the bottom here, what would we call that straight down of the triangle? That's the height of the triangle, right? Can you figure out the height of this triangle real quick on your calculator? This would be what? 9 times sine of 30. Figure it out. I want you to have it on your calculator. Is it 4.5? Okay. What's the side length here? This is the SS, right? Angle SS. In this case, it's shorter than the height. There's no triangle, right? So what if we were to extend that? So if I get it to 4.5, it's going to be very hard to do, but I'm going to try. Oh, perfect. What kind of a triangle is possible there? It's a right triangle. Boom, exactly 90 degrees here, because we match the height of this thing. So the side length here, that other side length is 4.5, so exactly one triangle. So there could be no triangle shorter than the height. This is gonna be, oh, come on, work with me here. See, there. If it's exactly equal to the height, you've got one triangle. But what happens if this length is longer than the height? How many triangles are possible? And so you focus on There's this big one here on the outside. You see this? Notice that it's B1 and B2. So there's one triangle that would be possible here, but there's also one that would be possible if it swings in right here. You see this one? That is the other one that's possible. So that's what we're going to talk about today, okay? To determine how many triangles are even possible here. One more thing. What if, you notice that 7 compared to 9 is smaller, right? 7 compared to 9. If this side, and I always made sure this was the case, if this side here is longer than the first side, so the string, if it's longer, can you see it? I don't know if I can pause it. I can pause it there. If it's 10.9 compared to 9, there's only one triangle possible. And you're like, well, Mr. Dirksen, it's swinging over here. What's up with that? No. You only focus the way that it's pointing, right? The 30-degree angle is pointing this way to the right. So there is only one triangle possible there. And I made sure that every single time you had an SSA, that the string, quote unquote, was longer than this other side. So you didn't run into this problem. Okay? But now it's going to change. So let's do some of this on paper. So you want to force, right, your diagram to look like this. And then we ask. So this is step 1. You must, I don't know, unless you're a genius, which I'm not, right? Step 1, I would draw my triangle like that. And then you have to ask, is the string greater than or equal to the rod? Okay. Why equal to? What kind of a triangle would we have if these two are exactly the same? Isosceles, right? It's still there. You have an isosceles triangle. So if these two are exactly the same, right, or greater, if the answer is yes, right, if you can say yes to that, you have one triangle, one solution, one triangle, same thing. Okay. Oh, you can't see that, sorry. I'm too excited when it comes to ambiguous triangles. It's hard to teach, right? I will say this, note, if a string is equal to rod, that's an isosceles, right? I don't know if you can see that, but a string is exactly equal to rod, it's an isosceles triangle, that's it. If it's greater than, it's still one triangle, but it's not isosceles, okay? So keep that in mind. If you're asking this question and your answer is no, right? So basically string is shorter than the rod. That's really what you've concluded, right? Then you have to follow the next step here. You have to find the height of the triangle. Height of triangle, you know this one. I gave this away. If you look at this diagram here, there's only one way to find it. B times sine of angle x. I called it x here, right? You will have to follow that step. And based on this answer, guys, you will go down one of these paths. Only one. Okay. By the way, you only end up in one of these extremes, right? The ends. That's all. You still have time, so I will walk you through it. If string is less than height, and you can tell yourself string is shorter than height. If you want to actually write that, go for it. But if the string is less than the height, you have no solution. No solution. No triangles. That's your conclusion. And if you look back at the at the app that I just showed you, it would essentially show you one of these, right? It would just, this is your string, this is your rod, right? And this is the height. It would just keep swinging. You can't close it. You can't close that triangle. It's physically impossible with the amount of string you have to close that triangle, so no solutions. The other one is if the string, you know, the dangling part is exactly equal to the height, how many triangles? One solution, right? It's at 90 degree, it's a right triangle, specifically a right triangle. And it will look like this. This is your rod, and this is where the string is exactly equal to the height. I hope that makes sense. And then the last one is the one that will be the most work, the one you don't want, but it will be presented quite often. It's if the string is greater than the height. That's when it swings both ways. Remember, it swung in and it swings back out. That's your two triangles. So two solutions, two triangles. Why are you keep saying that? Because sometimes students are thrown off. It's like I ask how many triangles are possible, and then another time I will say how many solutions are possible. It's the same thing. It's like roots, x-intercepts, it's all the same thing, right? Solution. So this swings like that. One of the triangles will look like this, right? It swings in. So this is your rod, and that's your string. Where's the height? The height is right here. It's outside the triangle. Okay? And then the other one will swing out, so it will kind of look like this. Where this is your rod, this is your string, and your height is inside here. And now I need to, at the very end, just give you the justification, like how we would write it. If you go all the way from the top, for all three cases, guys, all three cases, the string is shorter than the rod. String is short, right? We determined that way upstream, that for all of these cases, the string is shorter than the rod. That's why we had to go down this path to begin with. And then for all of these, we compared what? The string and the height. The string and the height. The string and the height. So the first step is always comparing the string and the rod. Then the second step is comparing the string and the height. For this particular case, what did we determine? That the string was shorter than the height. Here, the string was exactly equal to the height. And here the string was actually longer than the height. So this is the, from time to time, I'll ask you to justify using the correct notation. And I think, yeah, it's good. Yeah, we'll leave it like that. So this is my, this is the best I could come up with, guys, to like visually put it down on paper, as opposed to just like write this all down, right? Line, 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 line. This is like a little bit of a flow chart. Okay. I hope you wrote this down. It's still recorded, but you know. What else do I want to see before I move on? Trying to think of common mistakes. I'll think of them as I go through this. Yeah, make sure you write this down. I'll pause a little bit. Ready for this? I'm going to go up, and I will make sure that I highlight that. This is acute only, like the angle that you're given, this angle right there, the only one that you'll be given is acute, right? So how about we make this green, right? That's acute, boom, right? That's what it will look like. So highlight acute at the top and make sure, like all of our triangles, if it's acute, will look like this. You're still fishing, I call that. If it's acute, you're still fishing. If it's obtuse, you already caught one, you're reeling it in, right? So come with me to the next page here. We'll just run through obtuse. Highlight obtuse here and make sure you make note of that, right? This is how I want the diagram to look like. It still has the rod and the string, right? You still force it to look like this, but watch this. You never need to worry about finding the height. When it's obtuse, you don't have to worry about that. There's only two things you need to check. If the string is less than or equal to the rod, this is on page 36, no solution. You're done. If the string is greater than the rod, you have one solution. That's it. There are no two triangles or whatever. Those are the only two options you go down. So obtuse is actually quite simple to determine right away, just like that. Just compare the string and the rod. You do that anyways. That's always the first thing you do, string and rod. And then you determine the height, but not with obtuse triangles, only with acute. Okay? I know it's going to be a lot of information today. I get it. But I test is Tuesday, so I kind of want to make sure you have a lot of information today. So real quick, without doing any calculations here, let's go to 37. Okay, I hope you follow. Go to 37, and we're going to say how many solutions are possible here. And this is the one where, right, we determine that the rod, right, string, it's always string first, string every time, string is less than rod, correct? And the string is what compared to the height? Just look at the numbers. Less than height, correct? You would agree with that? You're thinking, well, it doesn't touch the ground, so obviously just look at the numbers. I will always make it be up, not closing, okay? Therefore, no solutions. No solution, right? There you go. Next, this is my rod and my string. I will say that string is less than rod, okay? Then I need to proceed and compare the string and the height. What about the string and the height? String is shorter, right? 11 is less than, so no triangles. Therefore, no triangles. See how this goes? Because this is what you will come up with after a while. You calculate the height, and then you'll know, right? Next. Here, rod, I would do this, rod and string, always like that. The height is there, okay? String compared to the rod, this is what's happening. String compared to the height, what's happening there? It's exactly the same, right? So how many? One triangle. It's a right triangle. in particular? What about here? Let's compare string and rod. Oh, sorry, rod is here. The string is there. String is what compared to the rod? Greater. Therefore, one triangle. Done. You don't even need to worry about the height anymore. This is what I gave you over and over. Every time you had an SSA, I made sure this is the case. Okay. Over here, string is less than rod, right? Because this is the rod, this is the string. And string is greater than the height. Therefore, how many? Two triangles, right? It swings. This would be swinging in, and it'd be swinging out, right? That's the ambiguity. It could be this or that. Remember when I gave you that question with the sunken vessel? Some of you drew it differently, right? That's kind of what's happening here. And here, what kind of a triangle do we have here? These are obtuse. I actually inserted that later on. You can tell it's a different font, right? Obtuse, obtuse, right? So all you check for is the rod and the string. This is the rod, this is the string, this is the rod, this is the string. And what's the height doing there? Why did I include the height? To just test you. Would you worry about it? You don't, right? Here, the string is less than the rod, right? Therefore, no solution. Oh, Mr. Dirksen, what's going on? 1.03 is bigger than 1.02, right? Let's get that straight. So therefore, how many solutions? It's actually one. It's a 0 or 1 with obtuse. With obtuse, it's 0 or 1. One triangle. Over here, string is less than rod. I think I got that one right. Therefore, no solution. Done. Because they're obtuse. If this had been 83, what if this had been 83? 83, 83. Still no solution. Because think about it. If this is exactly the same as that, it would just swing like this, right? And just basically line up with the rod. I feel bad for you, but I still want to do one more. I know it's heavy. So heavy. This is really what I want you to practice today. If everything else, this is what I want you to focus on. This kind of stuff right here. This is test material right here. Okay? You're with me? 38. 38, 38. So stretch, do whatever you need to do, guys. I'm tense already. Okay. You with me? The first thing I want you to look at is the angle. Or I should say, is this SSA? Determine if it's SSA. If so, how many solutions are possible? And we'll justify. And justifying is drawing the diagram, doing all that stuff. Okay? So is this SSA? There are two sides, right? And you see that there's a pair. Pair plus side. That is definitely SSA. So that means that I have to go through the flow chart there. What kind of a triangle is this? Acute or obtuse? Well, in terms of the angle given, it's acute, right? So we determined that it's SSA. Then we said, hey, it's acute, which means that I'm going to force this triangle to look like this. Okay? And the ground is kind of there. So that's my angle A here, which is 37. And I will put side A across from it, right? Because that's how it has to be. So this is side A, which is 220 8.3 feet. And therefore, I will just make side B be over here. Remember, this is a pair. They need to be across each other. And the other one, you'll just put it over there. We'll make this the rod, and we'll make this the string. So remember, you always ask, compare the string and the rod. And what do we notice about those numbers? String is larger than the rod. Therefore, one solution. Done. No need to find the height or any of that. You're done. Okay, you're done. Can you find the height? Sure, if you want to, go for it. It wouldn't change this. It would not change that. Next, is this SSA? I have a pair here. Pair plus side, and that is SSA. If it is not SSA, guys, how many solutions will be possible? Just one. That's it. You don't have to worry about it. There will be a triangle. SSA is the only problem. Okay. Okay, so and it's obtuse. You notice that? So I want your diagram to be like this. Right? So you put the 127 here, and that's angle Y, and then you just make your string go like this. And remember, side Y is across the angle here, and Z is 30. We're going to make that be over here. You're going to make this your rod, and this string. RS is fine. What about Y? You can call it Y if you want. That's okay. But so here you would say that the string is less than rod, therefore no solution. And you have your flow chart, right? Like have that flow chart, look at it, maybe make one for your study sheet, and then use that to guide you through it. I mean, you put it to the test, right? Triangle DEF. I see two sides and an angle, and I see that they're paired up. So I do know that this is SSA and that it's acute. Okay, SSA acute, so I need to go with this. And the angle given, which is angle F, I put it in that corner, and I make sure side F, otherwise this won't work for you if you don't put them across each other. This is 9.7. This might be a two triangle scenario right here. This is a candidate for that. Okay, so what I'm going to do here, I'm going to put an R and an S. And remember, string is the main character. String is the main character. String is less than rod, therefore find height. Right? When string is less than the rod, you need to find the height. So height is 9.7 times sine of 75. 9.7, right? The slant here times sine of 75. And I'll just give you that answer, 9.37 miles. And then you ask, back to string. String and the height. String is, look at the numbers. String is what? Greater than the height. And if that is the case, you have two possible solutions. If it's equal to, it's one right triangle. If it's less than, then there's no triangle, right? So sine is greater than, so these are very important. These are justifications to come up with that. So your homework is going to be pages 39. Oh, what did I do here? Oh, I made an update. That's what happened. 39 and 39, and I want you to try 40. At least one, like there's two that are similar. Just try the top. Okay. I will post the key to that. I'll post a key to that. And that's it. Oh, and remember, there's a workbook for this, for chapter 4. It says ambiguous case of the sine law.